Hello everyone, today I'm gonna explain what's the vertex point. The vertex points can be either minimum or the maximum value of a function. So let's think about the function which is written like f of x equals a times x minus r square plus k. So let a first be the greater than zero. So if we look for, like if you choose the impulse which is x goes to, like approach to the infinity. And in this case, the function f of x a times infinity minus r square plus k. And we know that the square of a number, which is really big one, can go to infinity. Since a is also positive, in this case, it will when x approach to the zero, it means y approach to, when x approach to infinity, y also approach to infinity. And in the same manner, if x approaches to minus infinity, which is, we need to write infinity here, which is minus infinity equals a times minus infinity minus r squared plus k. So we'll let a positive first, and the square of any number will gonna be positive, right? It will also go to positive infinity. So when x approaches to minus infinity, y will also approach infinity. And if we choose, so in this case, um, we know this that the parable, the quadratic functions, the graphic of these functions will be like the parable, right? So in uh, like when x goes to infinity, y also goes to infinity, and when x goes to minus infinity, y will approach infinity too. In this case, we are checking for the minimum points of the function. So how it will get the minimum point? We know that the square of a number which is here, if you write the function again, a times x minus r square plus k, if we choose here, we have that the minimum value of the expression, which will get at the point zero, the minimum value, and when x equals zero, r, it will be the minimum value, which is zero. So if we substitute the value r in the function, we will see a times r minus r squared plus k, which is a times 0 plus k equals k. In this case, we know that a is positive number, and we choose the minimum value of this expression, which is 0. So we find the minimum value of a function f at the point when x r and y equals k. So this is the vertex point of f. So if we let the a less than zero, and look again the function f of x equals a times x minus r square plus k. In the same manner, if x approaches to this infinity, we know that if we look for where it will approach, the y values, if we substitute like a big number, like with infinity means when substitute this expression, it means a really big number. So a times infinity minus r squared plus k, we know that since a is negative, and here it goes to infinity plus infinity, when we multiply this both number, it will goes to minus infinity, right? Yeah. Let me open another page. Yeah. So if x approaches to minus infinity, and we again substitute a really big, number which goes minus infinity, in this case, a times minus infinity minus r squared plus k. Since we know that a is again like negative number, and any negative, square of any number, which is even negative number, it will go to if the number is big, it will go to the positive infinity. So when we product, I mean, multiply this really big number, which goes to the positive infinity, with a, which is negative, the function and the value of the function, which is y, will go again the minus infinity. In this case, when x approaches, uh, when x approaches infinity, y approaches minus infinity, and when x approaches minus infinity again, y approaches minus infinity. In this case, we need to find the maximum value of the function. So when will the function will get the maximum value? So again, if we check the function f of x equals a times x minus r square plus k, so we know that a is negative, right? So if we choose this, the minimum value of the expression, which is x minus r square equals r, the function will get the maximum value because a is negative. So we're going to choose again x r equals r. So if we substitute this r and the function, we will see that a times r minus r square plus k will be 0 plus k, which is k, right? So in this case, the vertex point again uh, will be r and k. Yeah. Thank you for listening.